In the previous series, we look at how pressures are formed in relation to the atmosphere. Also, the work of Evangelista Torricelli, the Italian physicist and mathematician, was discussed in relation to pressure using a barometer. We finished off with, what is differential pressure transmitter? In this series, we will be looking at how differential pressure transmitters are used to measure flow and levels. Let begins with differential pressure transmitter with respect to flow. Differential pressure transmitters, delta P or dP as it is known in industries, were primarily designed to measure pressure. That is, before and after the fluid encounters an interruption. This interruption could be filter or pump. The delta P comprises of primary elements, secondary elements, electronic housing, and process flanges. The electronic housing features an amplifier board and wiring terminals. This instrument uses the primary and secondary elements to measure pressure in pipes. Of course, the pipes should be checked for pressure leaks within, and the flange should be properly fastened to the pipe in a way that will prevent fluid leaks. The primary element produces pressure with respect to flow within the pipe. The primary elements come in different forms, which include orifice plates, cone, venturi tube, pitot tube, flow nozzle, laminar flow elements, and wedge elements. One thing worth noting is, the primary element's selection depends on the process conditions. The secondary element usually measures the difference in pressure produced by the primary elements. By configurations, the primary elements are usually called the high side, while the secondary elements are called the low side. The elements in the DP transmitter have a sealing diaphragm. The diaphragm is used to convert pressure into electrical signals. The diaphragm uses vibrating wires, capacitance, and string gauge to produces the electric signals. The signals produced are sent to the electronic side of the DP. The signals sent from the diaphragm are processed by the electronic side of the DP. The processed signals are either current or voltage signals, which could be 4 to 20 milliamperes, 0 to 5 volts, or 0 to 10 volts respectively. The signals needed depends on the configurations of the PLC input module. The electrical signal coming from the DP is usually proportional to the actual pressure being measured by the DP. One thing worth noting is, the DP comes in ranges, but regardless of the DP range, 4 mA will equal 0 pounds per square inch, and 20 mA will equal the maximum range of the DP. Assuming our DP is at 250 pounds per square inch, 12 mA will be 150 pounds per square inch. Now that we have known how the DP works, let's look at its application. In today's industrial setup, differential pressure transmitters are used to measure flow and levels. Looking at flow, firstly, let's look at Bernoulli's equation. Pressure drop across the constrictions is proportional to the square of the flow rates. The flow rates are usually denoted as gallons per minute, GPM, or cubic meters per hour. Now let's look at how DP measures flow. The primary elements are usually used to create constrictions within the measuring paths. This will create a high and low pressure within the pipes. And as such, there will be difference in flow within the pipe. The secondary elements on the other hand will measure the differences within the pipe. which is the differences created by the primary elements. The measured values will be sent to DP for further processing. DP transmitter will work best with liquid that have less viscosity, and also free from dirt. Hence, in some setup, filters are usually put just before the DP transmitter. There is a lot of different solution in the market for measuring and monitoring liquid levels. For closed vessels, operators commonly choose a differential pressure transmitter. This is a proven technique, especially when the measuring instrument should not be immersed in the media, such as for tanks that have a grinder or hold aggressive substances. And the container or the vessels are usually enclosed. In a close tank, the atmospheric pressure is of low sequent for level measurements. The transmitter measures the pressure within the liquid column and liquid head. Values are transmitted to the transmitter via the oil fills capillary lines, or through the pair of sensor modules connected via interconnected cables. The transmitter calculates the difference between the two capillaries or the sensor modules. This calculation will determine the liquid levels. Warning: to prevent injuries, damage to equipment and property, the tank must always be depressurized before removing the DP or its associated device. In summary, there are several solutions in the market, but the working principles are all the same. There are several types of this device in the market. If you want to learn more about this device, kindly search for differential pressure transmitters on Google. Now let's recap. We started with pressure as related to the atmosphere. We look at the contribution of Evangelista Torricelli in relation to barometer. We also spoke about differential pressure transmitters. From there, we talk about how DP transmitter convert pressure to electrical signals through the use of diaphragm. We also look at differential pressure transmitter as related to flow. Finally, we end up with differential transmitter as related to level. Hope you have learned today. See you in the next units.